Interference pattern of double slit experiment is simply a sinusoid with wavelength depending on the slit distances. Interference pattern of triple slit experiment is the addition of two sinusoids with wavelength delta y and delta y by 2. Interference A pattern of 4 slits is addition of 3 sinusoids with wavelength delta y by 2 and delta y by 3. Here first image is interference 10 slits, second of 25 slits, and third of 100 slits, but all slits distances are multiples of d. In other words, every adjacent slit is d unit aparts. From the images we can conclude that wavelength of the Fourier function is same as double slit experiment. 10 slits is equal to 10 delta functions of intensity. So first image is equivalent to Fourier transform of 10 delta function, second of 25 delta function and third of 100 delta function all d apart. We also see that Fourier transform of a very large number of delta function is equal to a large number of delta function. This is consistent with the theory of Fourier transform. The first image represents interference patterns from 1500 slits with 15 combinations of D. Second image represents interference pattern from 3000 slits with 30 different combination of D, and third image represents interference pattern from 6000 slits with 60 different combination of D. We see that on increasing the combinations of D we are reaching the desired sin function produced by the Fourier transform of the box function. Finally, let's see some examples of circular slits. A circular slit has intensity of a cylindrical function and its Fourier transform is sin function. As we increase the cylinder's size, sin function main central feature enhances while its outer features are cancelled out. Finally, a large enough cylindrical function will create a Gaussian.